Hi guys, this is Daniel here. My number is 40771529. Today I'm presenting a greenhouse smart control and monitoring device. Now over here I have my simulation schematic setup over here, where I will take you through the component, the part, the individual sensors that I use for my project. Now over here, when you come to uh, this section, I have 8051 microcontroller here, which is the main brain of the entire setup. I also have crystal oscillation circuits attached to it. This is to make the 8051 work. Without the crystal oscillation circuit, the microcontroller will not be able to function. So apart from that, I also have my virtual terminal. A virtual terminal is simply a virtual display which can be used to control and monitor the setup from a remote area. And then we also have our LCD for local display. This is going to be at the local station or inside the farm, where you read the values from there. And then again, we also have ADC 0808. The ADC 0808 is mainly for conversion from analog to digital. This is because we don't have the ADC inbuilt inside the 8051. So this is an attached circuit that will be attached to the 8051 for us to be able to convert analog into digital. And then we have also a rest pack box over here. This is a box full of resistors. A box full of resistors, about eight of them in one box. One contains about 1k ohms. Now this is because there are some of the ports that will need to pull up resistors. Now this has a lower output or input. So basically what we normally do is just to put or install a pull-up resistor for us to be able to access the microcontroller. Then we have our sensors. We have our three sensors. What we'll be doing today is temperature, humidity, and then soil moisture. So what we are going to do is just to control the output with the input. So the input results will now be able to help us to control the output. Now the output, what we are looking at now is water pump. We are looking at extractor fan. We are also looking at heaters. Now on my project, I am using a neon lamp or a halogen lamps. These are powerful and high luminous lamps that can be used to generate heat. So for my setup, I'm using lamps to generate heat, and then I also have my water pump and then my extractor. The extractor is basically just to extract heat from the greenhouse farm anytime there's heat. So I'm going to go ahead and then operationalize the setup. So go ahead and simulate it. So in the first place, I have my system initialization display on. So what happens after this? You will receive a welcome note. This is Akwaba. Akwaba is basically in a local language in Ghana. So after that, you go to a welcome. I also have a serial number. Then we'll begin our simulation. Our simulation begins. It goes through a series of simulations. So what we have here is that we have soil wet at the moment, temperature at 0.31. For my parameters, I am looking at temperature greater than 29, which will be able to start the fan. So I'll go ahead and then increase the temperature. This is my temperature. If I increase the temperature, or if I decrease the temperature less than or greater than 29, I should be able to turn on the heaters or the fan. So my parameters are set that anytime the system or the temperature goes above 29 or 30, the fan comes on. So we increase the value from 29 to 30 to 31. Then we'll be able to monitor and check if it is above, the extractor fan should start. As you see here, the extractor fan has begun, and once it comes below the set threshold now is 35. So go ahead and try the heater. We also have our heater here. So in our setup, what we've done is that anytime the humidity goes above or greater than 39, the heaters will come up automatically. So this is 41. Now we have our heaters on. As I said, I'm using lamps for heaters. And then also our soil moisture, anytime the value goes above 40 or less, it's either it turns on the pump or it turns off the pump. So now it's below 40, so go ahead and try it at 40% to confirm that our pump is working. So basically, this is a simple or a short tutorials on how my system works. Thank you.